Hey, hi there. In today's video, we'll be exploring descriptive statistics. So statistics can be broadly divided into two parts. One is called as descriptive statistics, okay? And the other one is called as inferential statistics. So in this descriptive statistics, we basically learn about those parameters, statistical parameters, which we calculate to describe my data. What is the average? What is the standard deviation? What is the spread of the data? What is the maximum value? What is the minimum value? All those things. Whereas in inferential statistics, whatever parameters we have calculated, mean, median, mode, whatever it is, how correct are they? How confident are we that that is the mean of the data? Because the data which I received, right, is a part of a bigger population. So how good my data is. So all these things can be further, evaluated using inferential statistics. So that is where we start drawing inferences from the data. Okay, but for now, let's start off with descriptive statistics. And today will be the first part of descriptive statistics. So we have divided the descriptive statistics section into two parts, 1 and 2. So let's start with the first section today. So descriptive statistics, what does it consist of? It basically consists of 4 parts. One part talks about the measures of frequency, like what kind of parameters we use to calculate frequency of data. What is frequency again? Frequency can be related to probability as well. Frequency means the number of count of a particular number or particular entity. That is called as frequency, the count. So frequency, percentage, cumulative frequency, all these comes under this umbrella. Next, we have measures of central tendency. This is very important because that is where we will try to understand mean, median, mode. What is the central tendency of my entire data, right? So if I have the entire data and I sort an ascending order of magnitude, what is its central tendency? What is the value which is the average, or can be the median, or can be the mode? That is what measures of central tendency mean. Then we have measures of variation. Variation means the spread of the data. How much spread does the data have, right? Talk about variance, standard deviation, coefficient of variation, etc. Lastly, we have the measures of location. Now, this is also very, very important, guys, because that is where we try to understand the percentile and the quartile ranks of a data. We'll talk about all these things in proper detail, right? We'll also know. We'll also get to know how to calculate them using a programming language like Python. Okay, so for today, we'll start off with these two topics: measures of frequency and measures of central tendency. So what is measures of frequency? Frequency is the number of times a particular data point occurs. Very simple, right? Cumulative frequency means sum of all previous frequencies up to the point. I'll again explain it to you with the help of table. Suppose we have this series of data or array of data, right? The marks awarded for an assignment set for a year class 8 of 20 students vary as follows. Create the frequency table for the above distribution of marks. So if I want to calculate the frequency table, just like we used to do in class 8, 9, 10, that is how we do it, right? I'll first find out all the unique data points from these data, right? I find out all the unique data points from this array of data. And that is what I've done here in marks xi, 4, 5, 6, 7, 8, 9, 10. These are all my unique data points. And then I'm going to find out how much frequency does each of these data points have. How much repetitions does these data points have in that particular array. So if you look at here, you go to the previous slide, 4 occurs how many number of times? 2 times. So what I've done is I've simply extracted the unique data points and then found out the number of count, right, of each of these data points. Now, how do we calculate the cumulative frequency? Is very simple. The cumulative frequency, first, this particular 2 which you see here, this particular 2 goes here. Okay. Then we add this particular 2 to give me 2 plus 2 is equal to 4. Then again, this 4 will be added to 4 to give me 8. And again, this 8 will be added with 5. So the present cumulative frequency gets calculated, added to the next normal frequency, and then we get the next cumulative frequency. So that is what it means. CFI plus CF plus FI plus 1. CFI plus FI plus 1 equal to CFI plus. That is how we typically try to calculate. Okay, very simple. So let's take another example. The number of rolls, the number of calls from motorists per day for roadside service recorded for a particular month. So how many number of calls have been recorded every single day by passengers traveling on a roadside, right? So these are number of calls which we receive, help calls basically, 28, 122, 117, whatever it is. Now, if I want to find out the frequencies of such data points, instead of finding out the unique values, because here if you look at number of calls, it is a bit difficult to interpret unique number of values. Each of these data points may be unique because data seems to be continuous here, guys. Remember continuous and discrete data, which we studied in introduction to statistics, different types of data. That is what exactly this is all about. Now, if you go to the previous question which we had, here these data points seem to be discrete because the range is not that high. The number of unique elements is less. Repeating elements are more. But here, if you go here, the number of unique data points are pretty high. This is where you have to create intervals because this data seems to be continuous. So the way we calculate cumulative frequencies or frequency for discrete and continuous data is different. Hence, we use different distribution plots. For the previous example, I was using a bar plot in visualization. But for this example, I'll be using a histogram or a distribution plot. Because in distribution plot, we do the interval creation. But please don't worry, we don't need to calculate these intervals and so forth. We don't need to do that. I can simply give this data to Python, and then if I asked it to do a distribution plot, it beautifully give me all the frequencies and the probabilities associated with each of these intervals. So we don't need to worry about it. So if you look at here, 0 to 4, that is how the intervals are created, and each interval is of equal length. So here, if the length is 40, in every interval, the length will be 40. And that to 0 to 40 is continuous. 0 to 40 open bracket means it does not include 40. So this basically means greater than equal to 0 and less than 40. Greater than equal to 40 and less than 80. Right? When you have a round bracket, it means it does not include that. When you have a square bracket, it means it includes that. So it's continuous data, guys. 39.99999 will also fall here. 40.000001 will also fall here. 40 itself will fall here as well. So 0 to 40, how many elements are there? We'll record it 1. 40 to 80, how many elements are there? There are 7 elements. 80 to 120, how many elements are there? That is 14 elements. 14 number of data points are there which belong in this range. And that is how the way we calculate cumulative frequency is exactly what we had done before. Right? One will go here. Then 1 will be added to 7 to give 8. 8 will be added to 14 to give us 22 and so forth. So the last number basically indicates how many data points were present in this particular problem statement. The previous one also, cumulative frequency will give me how many total. Now the last cumulative frequency will give me how many data points are present in the entire data set or data array. Why are we doing the binning now? Why are we creating intervals? Please understand, if I would have considered each of them as discrete data points, what would I have done? I would have, simply calculated all the unique values. Maybe I have say 35 elements, 35 numbers here, out of which say 33 of them are unique. Okay, so in the x-axis, how many elements will be there? How many unique numbers will be there? 33 number of unique numbers will be there, elements will be there. And what will the frequency of each of them? Except for 2 data points which have repetitions. Rest everywhere the frequency will be 1, right? Because they're repeating 1 time. And only 2 data points will be there whose frequency will be 2. So such distributions do not make sense. It especially does not make sense when we have too many unique values in my data set. And that happens typically when data is continuous. So rather than looking at integers or floats, we should better look at, how much uniqueness does this data points have. And unless until you plot it using Python, you will go and get to know, because looking at the data point, it becomes difficult. Now, We have 35 data points here. It is easier for you to understand. Imagine tomorrow we'll be dealing with thousands and thousands of data points. Looking at the data point visually, it's not possible for you to predominantly understand whether it's a continuous or discrete. Some of them will be very easy for you. Some of them will be difficult. So for that, we need to do some plotting. You put junk input to Python, it will give you junk output. That is the beauty of it, right? So if this data was supposed to be continuous, but you had treated to be a discrete, and if you do a bar plot on these numbers, you'll get many number of bars. Then immediately you'll get to understand, oh, this data should have been continuous case. Let me plot a distribution plot and check. That is how Python helps you out also to make judgments, to draw inferences. So trial error method will be used in statistical analysis also. So now if you look at this frequency table, difference is equal to highest minus smallest value. So how do we calculate the interval width? It's very simple actually. All we have to do is we take the difference between the highest number, the maximum number, and the smallest number. And then we basically, choose the interval of width 40 or whatever it is. And then we divide this range divided by the 40 will give us how many elements should be there, how many number of intervals should be basically there. Minimum number of intervals should be 5 here. So we have here 6 intervals. But this process, you do not need to remember at all, because this is something which a Python will automatically do it. Okay, you don't need to go into those mathematical details. All we need to understand is what kind of process I use, how's the frequency calculated, why is the interval being created for this kind of data set. That is what is more important for you to understand. That is all we had for frequency calculation. So we got to know how to calculate frequency for a discrete table like this, or discrete data points rather, I would say. And we also got to know how to calculate frequency for a continuous data set. Based on this, we do the visualizations of count plot and your distribution plot, right? Okay, all right. Now, measures of central tendency. What do we understand by measures of central tendency? Okay, let's see. Now, when we talk about measures of central tendency, the first 3 parameters, the triple M's, sometimes we call them as the triple M's. M, mean, median, and mode. That is what we typically understand when we say measures of central tendency. Mean, what does mean mean? The average of the entire data set. Now let us here have a data set where we have the marks and the frequency as well. Okay. Now, if how do we calculate the average? The average is very simple. Whenever we have frequencies, especially when we have frequencies in a data set, my formula is something very simple. I multiply all the unique values of the data set by its corresponding frequency. And then I divide it by total frequency, which is nothing but the number of data points in my data array or data set. That's it. Correct? Or you can call it as total frequency. Okay, same thing. Even if we have done 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 6, that's same thing. Here I've, to reduce the effort, I've calculated the frequency out, multiplied the frequency with the unique X values, and then divided by total frequency. Same thing. Okay. All right. So the next measures of central tendency is median. So now what is median? It's the middle number in the sequence of numbers. Okay, if you have a sequence of numbers, especially in ascending order of magnitude, guys, this should be ascending. Okay, ascending sequence of numbers. Yes. So, for example, we have 4, 5, 6, 7, 8, 9, 10 with ascending order. It can be floats, it can be anything. Okay. First, we sort the data in ascending order of magnitude. Then, when n is odd, okay, median is also equal to middle value. When n is even, number of elements, n means total number of elements my data set is equal to even, then my median will be equal to aim of the middle values. Now, what do I mean by this? Now, if I look at this data points, right, we have 4, 5, 6, 7, 8, 9, 10. Suppose we have 7 values here, right? So 7 values, n is equal to 7. So n is an odd value, right? So my median value is nothing but my middle value. What's the middle value here? The 4th value, which is 7. That is my median. But if we have an 11, another number here, what will it become? Then we have to take the average of the 7th and the 8th value, which is 7.5. Right? Correct? So that is what it basically means. Very simple concept. Now, this is what we had done in case of, say, a normal simple data set, right? All the values were unique here. It did not have any repeating values, 4, 5, 6, 7, 8, 9, 10, right? So in case of data rate frequency, we calculate that cumulative frequency, which corresponds to 1/2 of the total frequency. And with respect to that cumulative frequency, the number which is attached to it is my median value. So what are the steps involved? First, we sort the data, then we calculate the cumulative frequency. Median is that value which corresponds to this particular cumulative frequency, which accounts for 50% of the total number of observations in my data set. So if I have a data set like marks and frequency, what I'll do next calculate, I'll calculate the frequency and the percentage cumulative frequency. So if you look at the cumulative frequency here, I just pay attention to the part which I'm teaching. So we all know how to calculate cumulative frequency. So for 2, what is 2? What percentage is 2 out of n? All you have to do is 2 by n. 2 by n is here, 2 by 20. So 2 by 20, 4 by 20, 8 by 20, 13 by 20. And if you look at this, 2 by 20 is obviously less than 50% of 20, right? 4 by 20 is again less than 50%. 8 by 20 is again less than 50%. But 13 by 20 has crossed 10. 10 by 20 is 50. So 13 by 20 has crossed the 50% mark, which is 65%. So this becomes my median value. This becomes my median value. So if you look at this, so here cumulative value, which is 13, amounts to 65% of n, which is 20, and the corresponding marks is 7. So this becomes my median value. Okay, very simple. But again, you do not need to remember all these things, right? It's basically what median does is median is that value. If we arrange the entire data column or array of data in ascending order of magnitude, the middle value will always divide the data set into 2 equal halves, right? And that is my median value. That is why we're looking for the 50 percentile of the number of observations. So if you look at the basic difference between median and mean was frequency multiplied by the x plus frequency multiplied by x2 and so on, right? So it takes the magnitude into account when you talk about mean. When you talk about median is not about the magnitude. It's more about the position, the middle value, the middle position, right? How did we calculate 7 here? 7 got calculated not from the magnitude of 4 plus 5 plus 6 plus 8. It got rather calculated from the position, from its position, which is the middle value which it occupies in the entire data. And if we have frequencies attached with it, simply looking at the middle will not work. We have to find out the cumulative frequency, which accounts for 50% of n. But we don't need to worry about it. All these things can be calculated with just one single line of code in Python. So when we go to the Python application part of this today's lecture, you'll see how easy it is to calculate. But these things are somewhat necessary for us to understand so that our basics remain clear. The difference between mean and median, I've explained it right away so that later on, when you move to EDA processing, right, exploratory data analysis, that is where when we do missing value imputations, will you use a median to replace missing values or a median to replace missing values? In what kind of scenarios? In what kind of distributions? All these things are interlinked, guys, and it's going to be very, very interesting. Okay, right. So the next measure of central tendency, which we have out of the triple lambs, is mode. Now, what is mode? It is the data point that occurs most often within a set of numbers or set of data. Okay. Basically, it is that data point whose frequency is maximum. Suppose we have marks. So always try to understand concepts with the help of examples. It becomes very easy. Suppose we have marks 4, 5, 6, 8, 9, 10. And these are the corresponding frequencies. And what will be the mode? The mode here will be 7 again, because the corresponding frequency which is attached to it seems to be the highest of the lot. That is why the mode will be 7. So if you look at the previous median value also, it was 7, the same data points. So here median is also 7 and mode is also 7 because my frequency is high. And median is equal to mode typically happens when you have a very good distribution. We'll go to that as well. Okay, we'll go to that as well. Now guys, whatever mean, median, mode we have calculated was for data points where we saw there was certain frequency attached to it, but they were typically of discrete data points, like if you look at that in that way. But when we calculate the mean, we did it for two kinds of data. One was discrete, the other one was grouped data, right? So let us take an example of the group data again. And in many, syllabus, especially your school or college syllabus, you'll be getting some kind of concepts where we have to calculate median mode using specific formulas, and these formula are typical for group data points only. Data set where we group it continuous, but please do not get but you do not have to remember all these formulas. I'll show you today in this video for the sake of doing that. But trust me, when it comes to programming languages, we don't remember any formula. It will help us calculate the same exact median mode value with better precision and accuracy. All we need to know is understand the concepts behind it. Okay, so just to give you an example, suppose this is my grouped data, and we already did that, right? We got an accuracy mean value of 110.3, where all these values were lying with this kind of frequency. Then of this group data, how would you find out the median class or a median value, rather, I would say? Now, when we have to find out the median of the grouped data points, we first find out the median class. Okay, and the median class corresponds to the nth by 2 interval, right? So if we have 35 data points here, so 35 by 2 is how much? 17.5. So if we keep on going below, just like we did it for discrete data points, right? That particular data point or interval here, it will be interval, which corresponds to 50% of my total cumulative frequency or total number of data points. So here, if you look at it, 1 plus 7 is 8, 8 plus 14 is 22, which has crossed 17.5. So this becomes my median class, which is nothing but a third class here, right? And median L1, right? So median value is equal to L1 plus this formula, where we have all these different set of formulas to get the median value, which is 107.1 calls. So this data set was for the motorists, passengers data set, right? Calls per hour in a day. But please understand, we don't remember all these formulas because this is something which Python inbuilt will calculate and give it to you. We don't need to go through all these formula and remember it. These are all statistical formula which researchers used to use when did not have programming languages. They used to do this manually. So now we don't need to do that. But I'm still showing you for the sake of doing it so that you can relate to what we're doing in your colleges and schools. But this is outdated in a way. Okay. So next we have the mode calculation. So for mode, similarly, just like we calculate the median class, for mode also we calculate the model class. Okay. So model class is nothing but that class which has the highest frequency. So highest frequency again is nothing but this one only. Here also the mode and the median class is the same, interval is the same, right? So mode ka formula is this, and with the specifications we can easily calculate the frequency of model class, frequency of previous class, frequency of next class, whatever it is given here, right? And then we calculate to be 102.3, almost slightly different, a little bit of difference is there, right? That is how we calculate the mode. But again, in Python, one single line of code, that's it. We don't need to remember all these formula. I'm still showing you so that you can relate to your college assignments or school work, what they are, school syllabus, what they are teaching you probably. Okay. So now I want to tell you something very important. Now, if you look at the mean, median, mode values, right? So my mode is 103.3. Median is 107 and mean is 110, right? So if you look at this, mode is actually less than the median and median is actually less than the mean. Median and mode, does not consider the values or the magnitude of the values in consideration. Mean is the only parameter which considers the magnitude of the values to calculate itself, right? So if you look at the distribution, what kind of distribution we follow? First of all, this is a continuous distribution, and typically continuous distribution we tend to represent in the form of a bell curve, the probability distribution, right? Now, if you look here, mean is slightly on the higher side. So what does it mean? On the x-axis, this is where my mean is, this is where my median is, and this will be my mode. Mode is that particular interval which is the highest frequency or probability. So my peak which you have will come here, right? And then it will slowly go down here. So you can see here, it won't be a evenly distributed distribution, right? There will be some skewness attached to it, especially in this condition where mode is less than median is less than mean, which means that mean is the highest of the triple M's. So mean will be on the right hand side because this x-axis only on in ascending on a magnitude from left to right. Obviously, it's a graph. So there are some extreme data points which is influencing my mean to be rather high or higher than the median and the mode values. So this is called as right skewed. This is called as right skewed. Here, mean is greater than median, is greater than mode. Does the data is right or positive? This is also called as right skewed or positive skewed. You can see here some kind of skewness is here. And mode will be that value which is the highest peak, obviously. Okay. However, if we have, let's say, if we have, mode greater than median, greater than mean, which means that mean is the least of all in triple M's. So my mean will be on the left hand side, then mode and median will be there, and the mode will be at the last probably. So something like this. So there are some extreme values on the minimum side, which is influencing by mean to be at the lower value. Right? Suppose we have, say, the normal range is say 10 to say 50, but suddenly we have a value which is 0.005 or something, like whatever it is. So what I'm trying to say here is, in this case, in the previous case where we had this, right? Suppose we have values say from 10 to 90, and suddenly we have one value which is 250. That's why it's influencing the mean to be slightly higher than it was supposed to be. Then it's compared to the median and the mode. Whereas in the next case, where mean is the smallest of the triple M's, there probably my range is say typically from say 50 to 100, and suddenly I have some small values of 3 and 4 and 5. So it's influencing the mean to be on the lower side. So the comparison of mean, median, and mode, the value comparisons, can indirectly tell you so much about the distribution of the data. Right skewed, left skewed, whether it has skewness or not. And if all of them are equal, it means it's a proper symmetrical distribution, which will be hardly be the case in the corporate world, right? Real data is never that perfectly symmetrical. You always have some kind of skewness. But the extent of the skewness is somewhat determined by these three values. So important are these values for us.